Hello, my name is Pim Jansen. I'm an advanced development expert responsible for the segment innovation in the heating and cooling industry. I would like to welcome you to this presentation on material solutions for the transforming residential heating and cooling industry. Recent years have been quite turbulent for this industry, and I think you may recognize the following statement. We all need to reconsider material choices to stay safe, sustainable, and reliable. And during this presentation, I will share insights on how key megatrends, recent global events, and changes in regulations affect your material choices. In the second part, I will elaborate on general suggestions what you can do to manage the associated risks, and how Envalior can help you with those and give several examples of our solutions. Let's begin by addressing the most important megatrend, our environmental impact. It's evident that climate change is on the way. Plastic waste is increasingly pervasive in places it shouldn't be, and we're depleting our energy and freshwater reserves. Over the past few years, both consumers and governments have grown increasingly aware of our environmental impact and recognizing it as a pressing issue and taking proactive measures. There's now a real push for more sustainable and circular products. Within this industry, water and energy consumption have traditionally been key concerns. Additionally, we see a clear energy transition in this industry, a shift towards reducing reliance on fossil fuels for heating and cooling, alongside with a heightened focus on employing sustainable and circular materials to minimize product manufacturing footprints. These trends demand attention and cannot be ignored any longer. So let's dive deeper in how this trend, along with other macro trends, affect the industry. So these macro trends really provide changes, but also big growth opportunity for the industry. Governments and consumers are investing more money to become more energy efficient and less dependent on fossil energy. Simultaneously, the fast-growing middle class is also investing more money in comfort in and around the house. This is further accelerated by COVID-19, which changed the way we work by applying a virtual-first culture. We simply invest more money in our home as we spend more time at home. So what does it mean for the industry in heating and cooling? So for new buildings, the isolation is often much better, and the desired low-temperature floor heating is sufficient to provide comfort. Fossil-free heating and cooling is therefore more common practice, and in many countries even obliged by governments for the most new houses that are built. Gas and oil heaters are less needed for new houses as they will be equipped with heat pumps and solar energy systems. And lately we do see that the electricity grid is not always ready for increased electricity consumption, which is somewhat slowing down this adoption. So for renovation of existing houses, the government guidance and consumer needs are somewhat different. I have that on the next slide. So for renovation work, there's also a clear wish to become less dependent on fossil energy, to reduce the energy consumption and to increase the comfort. For relatively new and well-isolated houses, it is technically still possible to become fossil-free, but it's still a big investment to switch to low-temperature heating and to heat pumps. So for all the less isolated houses, the total investment cost and space needed to become fossil-free remains actually a big challenge. So for renovations, most governments require hybrid heating systems as a minimum to reduce the fossil energy consumption. So to save more installation space and to improve comfort, consumers often also choose to have an additionally small instant flow heater, as you can see here on the slide. Also in every household, prioritizing energy management and cost efficiency is increasingly crucial. Internet-connected smart heating and cooling systems are streamlining energy usage and expenses. And solar energy is harnessed and utilized in real time or stored for later use. And electrical vehicles need to be charged, but can also act as a potential home battery. Next to that, you see automatic solar screens help to regulate the indoor temperatures and preventing unnecessary cooling. The significance of home energy management system is on the rise, ensuring comfort and facilitating seamless communications between all the devices. All these macro trends require you to increase the innovation speed. And this is also a big growth opportunity for you. You really need to catch to survive in general. You may expect that part functions are changing as well, and the design space becomes tighter, and as a result also the material requirements are changing. All those growth opportunities are great, but as if growth itself is not challenging enough, there are additional big challenges making your life harder. So let me elaborate on those a little bit. You must keep up with all the regulation changes. With recent big global events, people now also realize more and more that we are a very complex global supply chain. And lastly, consumers have high expectations. They want a good price, can easily find information online on brand performance. So choosing the right water contact material is becoming more and more challenging. In general, when choosing water contact materials, there are several key factors influencing the choice. Traditionally, many parts are made from brass, but this is becoming increasingly expensive. Especially for higher production volumes, plastics become much more attractive. Many companies often like to work with polyamides as they are tough and reasonably priced. For higher use and certification temperatures, you really need to have hydrolytically more stable or lower leaching materials. You can, for instance, think about polyamide blends, longer chain polyamides like polyamide 410 or semi-aromatic polyamides as shown here on the slide. When a part needs to be with a very high precision, typically they choose PBT, PPO or PPS, depending on the certification needs. Brass is still often used but becoming more and more expensive solution. Most common plastics to replace brass parts in this market are 6,6 and PPO. And for many parts, the performance in the application has been good enough, so they are widely available, affordable and good to work with, making them a preferred first choice. However, in recent years, these materials have become under increased scrutiny as regulations tighten. For instance, compliance with the new KTW BWGL, the German drinking water contact regulations, is becoming more and more challenging at high temperatures due to the elevated leachable levels of PPO and PA66. Furthermore, after years of use of this material, the design limitation of these materials have been reached. The room temperature mechanical performance of PA66 and PPO are constraining factors, especially significantly affecting the reliability of the parts in use and in assembly because they are working at the design limit. This constraints reduced further design flexibility and contributes to escalated development costs and timelines. Finally, for PA66, significant supply chain constraints have been observed. The raw material supply chain is predominantly controlled by 3 global companies. Multiple force majeures in the recent years have demonstrated a big impact on both price and availability. So regulation change due to increased toxicological insights have a big impact on development cost and drive the use to safer materials. In Germany, the new KTW BWGL regulation is recently put into place. In the US, there is a new regulation regarding lead. In Europe, harmonization of the European water contact regulations is expected to come in a couple of years. So all these changes typically are accompanied by large certification costs and long certification lead times. To give some examples of the impact of regulation change, we have seen that many warm and hot water contact components require a material change that the material is simply no longer certified due to the stricter KTW regulation. The regulation now requires a supervised sampling and the recipe check is stricter and more time consuming. Overall, this is increasing the cost and time of certification of both the material suppliers but also of the component manufacturers. We have encountered cases where this required a material or a design change, resulting in a big concern on reaching the relaunch date, but also large costs were made for these changes. And in some cases, even decisions made to discontinue the offering of the final application in Germany, for instance. In the US, the water contact regulation for endpoints has been changed. California Proposition 65 required lead-containing brass parts to be labeled with a cautionary statement. This is obviously a concern of negative brand exposure and cost to change the material. In Europe, lead is labeled as a substance of concern. It is, however, still unsure how this affects the future regulation related to the production of brass and also components made thereof. Despite that brass is installed as favorite material, switching to a lead-free brass is not always desired. The raw material and production costs will significantly increase. The more complicated parts, the bigger the production cost difference as machining becomes much slower and with worse product quality, leading to more quality issues. Especially for larger volume parts, the switch to plastics has really become much more attractive. The past years, we've painfully experienced the drawback of our global supply chains. There have been many disruptions due to geopolitical events, COVID disruptions, and a gradual change in automotive materials consumption. These severely impacted the cost and availability of materials, parts, and end products. And companies want to be less dependent on supply chain disruptions, and this made companies consider their contingency plans in relation to material choices, production locations, but also second sources. So with all these challenges, there is a serious risk to lose business or competitiveness if you do not act proactively. Material change programs requiring redesign and retooling is typically costly and take a lot of time. Demand of new compliant materials increase exponentially, and forecasting is not possible if the material is not yet qualified. A worst case is a product which is not yet certified or that raw materials cannot be supplied, leading to delivery delays and lost shelf space. We all know that the material or design change is a hassle and is costing a lot of time and money to select the right solutions. To meet the clock speed of current market dynamics, you sometimes need to innovate faster than you would have done in the past. With the increased speed, the risk of part failing at the consumer is also increasing. This risk and the earlier mentioned risk are something we all like to prevent. So what can you do to reduce these risks? On a high level, a global development partner is needed who can help you reduce those risks and accelerate brass replacements with low leaching, high strength materials, and of course application development support. This can help you future-proof your designs for regulation changes and large supply disruptions. It is important that this partner has several material options available, as each design will have its own challenges. PPS and high glass transition temperature PPA are very good materials up to hot water certified parts, but not always practical for complex parts as they require high temperature tooling and have a lower ductility. PA66 blends and low TG PPA have a concern on the German KTW certification for warm and hot water, but also on performance in use and in assembly. Longer chain polyamides, such as polyamide 410, can be a very good option for many warm and hot water certified parts. And for warm water contact parts, PA410 can actually improve the reliability in assembly and use, but specifically for German KTW hot water P1 parts, they are simply out of reach for this material. As you can see, each material has pros and cons, and technical support can help you make the right choices. I think Envalior can be that partner. We have a broad and safe water contact portfolio and supportive competences from material know-how to CEE and part design to prototyping and cost estimations. This helps you reducing risk and increasing the speed of your innovation. In the next couple of slides, I'd like to give you some examples how we can help reduce risks and increase your innovation efficiency with our materials and support. First one is 4T PPA. It can help provide more design freedom and part reliability for warm and hot water contact parts. The superior weld line strength retention of the 4T ACE WX51FC, as shown here in the plot, helped our customers to design thinner parts versus competition PPA and PPS. By doing so, it was easier to design a part that fitted the space and helped reduce the total cost of the project. There's also a second 4T PPA example, that's 4T WX11FC, which also has a good weld line strength retention and can be injection molded in water-based tooling due to its good flow and lower glass transition temperature. This grade allowed the customers to replace 6.6 in the hydraulic group components, which was no longer able to meet the new KTW regulation requirements. With minor adjustments to the water-cooled and complex injection molding tool, we have been able to switch it to a 4T. This prevented a costly and time-consuming full redesign of all the parts. As you may know, for PPS, flash is often an issue. It causes post-processing of injection molded parts, is aesthetically not pleasing, or it causes some flow restriction in the application. Arc-Cyclone PPS hot drinking water contact grades offer a good balance between flow and flash and provide a high quality, reliable and aesthetic looking part. In terms of mechanical performance, it's very much on par with competition PPS, as you will see on the next slide. Overall, the performance and aging of our Cyclone PPS, as shown here by the plots, has a good weld line strength retention, and strength retention is very similar to competition PPS. Due to the better flow and flash balance, Arc-Cyclone G40-20 DWFC provided additional reliability for parts where the initial weld line strength is challenging due to the flow critical cavities. Similar to the standard 40% glass-filled solution, our hot drinking water contact certified 30% glass-filled and impact modified PPS offers additional reliability when the part sees a lot of repetitive water hammer impact. Similarly, its toughness helps to improve the initial burst pressure. Cyclone PPS is also used in non-drinking water contact parts where productivity and high temperature hydrolysis resistance and chemical resistance is key. You can think, for instance, of this condenser unit of the heat cell of a gas heater. Cyclone PPS provides an on-par part performance with similar competition materials and can be used in the same tools. This has helped some of our customers strengthen their contingency plans. Next to PPA and PPS, we also have EcoPax, a polyamide 410 drinking water contact grade, which allows for designs with thinner walls because of the higher conditioned part strength. This especially helps in reducing the failures in assembly of the part where a higher torque can be applied. So EcoPax has, for instance, replaced PPO and PA66 in instant flow heater components in the same tool when KTW regulation changes required a material change. So the alternative low glass transition temperature PPA was not able to meet the requirements due to the lower property retention. So key reason for the enhanced condition performance of EcoPax is the longer C10 die acid. EcoPax PA410 therefore absorbs less moisture compared to PA66 and even 50% lower moisture pickup versus a low glass transition temperature PPA, as you can see here in this plot. The hydrolytic strength is also improved compared to the low TG PPA. EcoPax QDWX10 shows about 30% higher strength after hydrolytic aging at 95 degrees in water. And that's compared to a low glass transition temperature PPA. So EcoPax allows designs with thinner walls or higher torque in assembly or higher bending strength with the same dimensions. Another often praised advantage of EcoPax is the ease of processing and its broad processing window. The high flow and lower crystallization speed result in an excellent surface quality and a better overmold stability, enabling really superb bonding performance to the metal. With EcoPax, parts can be molded with less internal stress and you have more design freedom. The last benefit of EcoPax to mention is the low carbon footprint of the base polymer, among others because of the C10 die acid, which is bio-based. When needed, the carbon footprint can be further reduced when we use a C4 diamine, which is bio-based via mass balancing. So besides helping you with water contact components, we also have a good track record outside water contact in, for instance, refrigerant contact, connectivity, and other structural parts. These are also areas where we can help you. And also before closing, I briefly like to show you an overview of our main drinking water contact materials and their certificates. Next to that, also our main non-drinking water contact materials used in heating systems are based in this overview. I will not go into all the details now, but the information you can later review in the slide deck. I hope our story on how trends are affecting your material choices has been insightful, and that it helps you reconsider how you make material choices so that you can make better future-proof plans and innovate faster. If you're interested in our solutions, I recommend that you reach out to your Envalio representative, look on Plastics Finder, or try out our new Material Advisor search engine where you can find instant answers to your material challenges. Thank you for joining. In case you have questions, feel free to reach out to me. Thank you.